Yes, now we are taking integration using substitution. Sometimes we have got a big expression to be integrated. We make substitution of part of the expression and we get the question simplified. It's better to explain with the examples. I'm taking as an example, you integrate say sine to power 5x and multiplied by cos x dx. This is the expression which we have to integrate. In this you see we find that this is a product and one of them has got a big power also. Seems to be a big expression, but a simple substitution will make it a very easy form. So we will say here, we say suppose or let that sine x, this part, be equal to t. I am assuming I am renaming that sine x as t. If you differentiate that, so when you differentiate sine x, it will become cos x, and if you differentiate that t, it will become dt dx or dt upon dx as you write, and that dx can be written this side. So we say in differentiation of sine x is cos x dx equal to dt, and then you will see that this expression, this part is present here, and then you will say sin x to be replaced by t, this is 5, cos x dx completely replaced by dt, and now this expression has been simplified to this simple form, and therefore this will be you know the formula, integral of x to the power n dx was x to the power n plus 1 divided by n plus 1 plus c. You will use it here. T to the power 5 will become t to the power 5 plus 1, that is t to the power 6, divided by this new part, that is 6 plus c. And then of course this integration has been completed. You have to just resubstitute, come back to the original variable which was x. You can write 1 upon 6 and t to the power 6 plus c, while this is 1 upon 6 and t was sin x. T was sin x. So you can say sin x raised to power 6 plus c, and you know that instead of writing it as sin x to power 6, we prefer writing sin to power 6 x plus c, and this is your answer. Is that okay? More questions, more examples will help you understand how we apply this technique of substitution and simplify the question of integration. If you have say integral of say log of x raised to power or 3 1 upon x dx, you can say if you consider, suppose or let that log of x as t, you know we have to differentiate now. You will say if you differentiate, because we are trying to find its derivative which must be present here. So differentiating, you will get 1 upon x. When you differentiate log x, you get 1 upon x with respect to x dt. And then you can see this expression 1 upon x dx is present here, same way as we did in the previous question. So rename, it will become log x was t cube, and 1 upon x dx is simply replaced by dt, and this converts to simple form. T to the power 3, use the same formula, integral of x to the power n is x to the power n plus 1 divided by n plus 1. Here it will become t to the power 3 plus 1, which is 4, divided by the new power 4 plus c, or else right here 1 upon 4 and this t raised to power 4, and what was t? It was log of x. This is your answer. Just one more question I will take, and that will be enough guidance for you people to solve others. If you have any doubt here, we can repeat, of course. I'm taking another question. Integral say cos x minus sin x divided by cos x plus sin x dt. This is to be integrated, and once again we are looking for the same technique where we substitute something, use of substitution. How is that done? Either this should be assumed as t. On differentiating, it should become its derivative should be present here, or if you consider this, its derivative present here. So we will prefer that the derivative should be present in the numerator. Like here, we consider, suppose or let this is cos of x plus sine of x. I am assuming it as a new variable, t or u or something you can rename, and then you check it on differentiating. What do you get? Cos x becomes minus sine x plus sine x. When you differentiate, you get it cos x dx can be written as dt. If you just rearrange, in fact this is here, we are just rearranging, this becomes now cos x, which was positive, minus sine x, which is present here, and dx as dt. And now you can see this expression is present here, cos x minus sine x dx. So this entire expression, this numerator is dt now, and this expression is t. I'm sure you can understand. Either say dt upon t, or you can say 1 upon t to be integrated with respect to t. And therefore, you can recall d dx of log x is 1 upon x. So integral of 1 upon x is log of x. So differential coefficient of log of t is 1 upon t. So integral of 1 upon t will be logarithm of t. Once again, I mentioned that wherever logarithm appears in this calculus part, it is always with the natural base e, not base 10. Okay. So 1 upon t to be integrated, that becomes log t. Even if the base is not mentioned, that is base e, the exponential or the natural base. And if you mention here, that is better, of course. So log of t, sometimes we write as ln of t also. T was this expression cos x plus sine x in the modulus sine plus c. You can notice that I have used instead of bracket, I have used here modulus sine or absolute value sine. What does it mean? You put the value of cos x and sine x and simplify. If it is positive, then of course the same value. If it is negative, convert it to positive, because logarithms are defined only for the positive values. Logarithms are defined only for the positive values. Logarithm is not defined for negative values. Logarithm is not defined for 0 even. So therefore, you have to keep it inside the modulus sign or the absolute value notation, so that you can say log of this positive value of this expression. I repeat once again, this was the question. We have assumed this denominator equal to t and checked it. I will mention here differentiating, cos x becomes minus sin x becomes cos x, put inside the bracket and mention dx equal to dt. T will be differentiated 1 dt, and then you can say rearrange. Cos x was positive, sin x is with the negative sign, put inside the bracket, dx equal to dt, and now compare here. This cos x minus sin x dx was present in the numerator. We are writing this entire numerator along with the dx replaced by dt, and therefore it has become now dt upon t, or we can rewrite it as 1 upon t dt, that is 1 upon t to be integrated with respect to t, which will become log of t. You can recall log of t when differentiated becomes 1 upon t. So 1 upon t when integrated will become log of t, of course with the base e. Even if you don't mention that base here, in calculus it is always considered to be the natural base or the base e, exponential, log of this expression. And whenever you write logarithm, you should always put the sign of absolute value function, which means that only the positive values are to be considered, because logarithms are defined only for the positive values. If you have logarithm of some numerical value, you can see it is positive or not. If it is some unknown form, some variable form, you have to see that expression has to remain positive. So we put it between the absolute value function. Okay, that's it. Thank you.